Alright, now the next tool that we're going to, on the next file that we're going to work with is clinicaltools.py, and this file is going to define the tools that lets the agent fetch the data live from clinicaltrials.gov API. Okay, alright, but didn't we already download the study data during the ingestion? Yes, we have, but that data lives in our Cloud SQL database. So why do we need these tools? There are three reasons. One is freshness, detail, and discovery. Freshness as in clinicaltrials.gov gets updated constantly. Okay, and a study that showed that results posted false during the ingestion might currently have posted the results. So these tools are going to fetch the current state directly from the source. Then detail, which means our ingestion pipeline stores a subset of fields. The full clinical trials GOV API response has hundreds of fields. When an agent needs a very specific field, we did not store. Okay, and discovery, which means an agents may encounter NCT IDs during analysis that were never in our original ingestion corpus, and that is the reason we're going to use these. Tools. Okay, so here you can see from ingestion.clinicaltrials client, we're going to use clinical trial client, document parser, all of them. We're going to create one more shared instance for document parser. Then we are going to use the same coroutine async function what we have done in the last other files. Okay, the first tool that I'm going to build is fetch study tools. Okay, it takes the NCT ID as an argument. What does fetch study details do? It is going to fetch the complete live record for one specific clinical trials directly from the API of clinicaltrials.gov. When do we use this tool? When you need the most current version of the study, which is the freshest data. You need the fields that may not be in our local database, or the study was not in the local ingestion corpus. And this tool makes a live API call slightly slower than our database queries, but prefers database search tools when the current data is not critical. This is what it takes in argument level, and this is what it returns. Okay, you can see it is using the async fetch function. Okay, and client, it is using fetch study, and it is basis the NCT ID. It is going to fetch the it is going to, now this fetch study is going to make just one GET request to this API endpoint. And what does it returns? It returns a raw JSON response as a Python dictionary. Okay, and it returns none if it's a 404. Okay, what do we get? You can see we are using fetch function inside run async. We're going to take raw study. If there is no raw study, which is the raw study is basically the data directly from the API. Okay, if it's none, that is just going to give you an empty JSON. Okay, that raw study we're going to take and we're going to apply parse study using the parser shared instance, and we now going to have a cleaner API response. If the parse study is none, obviously again we get a we get an empty JSON, not an empty JSON. Basically, it's like we're going to get a JSON, but it's basically unexpected API response structure. Okay, then we're going to just take that parse study. We're going to take model dump. So model dump is nothing but it's a pedantic method that converts our parsed study objects into a plain Python dictionary. So study dictionary is a plain Python dictionary. Okay, then from that we're going to pop the raw data, else none, which means we're going to remove the raw data field from the study dictionary before returning to the agent. Raw data contains the full original API response, and it can be thousands of lines of nested JSON. We don't want that, so we're going to pop it out. What do we return? We return a JSON dump, which is found equals to true, NCT ID, and the study dictionary. But this study dictionary is clean from the raw data. Okay, so it is going to have parse data only, and we're going to log the exception. Then we're going to build the second tool, which is search studies by condition. At an argument level, it takes the condition, maximum studies, and status filter. It is default, it is set to completed. What this tool is going to do, it is going to search the clinical trials GOV live for studies matching a particular condition. It is going to use this tool when you want to find the trials for a specific medical condition that may not be in our local database. For examples, find all the completed diabetes trials from the last 5 years, or search for cardiovascular trials from Pfizer, or find recruiting trials for this drug, etc. This tool is going to make live API calls. Okay, you can again just go in here. This is straightforward. It is going to take the status filter. Yeah, finally what does it return? Let's go to finally what it returns. That is where we are interested in. It returns a JSON which contains the studies, which is the list of studies, which is your research paper studies. Okay, count, the condition, and the status filter. Not the research paper studies, the trial studies, sorry. Okay, you can see here again we are doing the same job. We are taking the study dictionary, we are removing the raw response. Okay, we're also in here we are also removing the protocol amendments. Okay, because protocol amendments records are again very large and we rarely need them, so we're going to pop them also here. Going to the third tool, which is check the results posted. It takes the NCT ID, so it is going to check if the specific clinical trial has posted the results right now. Okay, we're going to use this tool, which is check results posted, when you need the current results posting status for a study. And this gives you live status from clinicaltrials.gov and not the status that is stored during the ingestion, which is it is going to give you very latest data. This tool is the most important tool for the missing results agent. Okay, a study that had no results during the ingestion may have posted results. Since then, this tool catches up. What does it return? It returns a JSON string which contains a result posted, which means if the results are posted then true, else false. Completion date, when the study was completed. Status, what is the current status of the study, and months overdue, which means how many months past the 12-month deadline. Okay, which is only present if the results are missing. Yeah. So here we're creating an async function called check. Okay, you can see basis the NCT ID, it is going to fetch the data. In the raw study, it is going to give the raw study, which is what? The raw API response. Okay, if there is no raw study, it is going to just give you a false, like an unnecessary API response or an unstructured API response. It is going to take that raw study, it is going to parse it using the parser shared instance. If none, then just give again, it's just going to say that could not parse the study response. If it does, it is going to give you a JSON which gives you an NCT ID. It is going to take the parsed NCT ID, which is the NCT ID from the parsed object, found true. Then the results posted again from the parsed version, it is going to take if the results are posted or not. Then status, completion date, sponsor. Okay. Now, if not, which means if there are no results posted and the status is completed, then it is going to look at the completion date. Okay, it is going to take the completion date. Okay, so you can see parse just the year and the month from the date string. Okay, and now is the date time, which is the current date time, and it is also going to look at the months since completion. So it is going to calculate the total months between the completion and now. Okay, so it is going to look at the difference year. It is also going to look at months overdue, which is month since completion minus 12. So subtract 12 because the sponsors have 12 months to post. If the month since completion is 58, we subtract 12, which is 46. So this is 46 months overdue that the sponsor have not posted the results. Okay, and if the months overdue are greater than 0, then it is going to, from the dictionary, from the results dictionary, it is going to get months overdue and the years overdue as well. And finally, it is going to take the exception error. It is going to log that error as well. Okay, we go to the final and the last tool, which is the get study amendments. Okay, what this is going to do, it is going to fetch the protocol amendment history for a specific clinical trial. We use this tool when investigating whether a study changed its primary outcomes or design mid-study, and this is the core signal for the broken promises agent. This is very interesting and a very serious case in research. Okay, now protocol amendments are official. They are timestamp changes to the study design filed with the clinical trials GOV, and they tell us what, when the study design was changed, what changed, and whether the change happened before or after the enrollment program. Here the timing matters because changes after the enrollments have started are more suspicious than the changes before the enrollment began. Yeah. So again, it works on the fetch. It takes the fetch function. It is going to fetch the raw study. It is going to parse the raw study. If not, that is going to give an empty JSON. Finally, if things work out fine, what does it give? It gives a JSON output which contains NCT ID, title, sponsor, found, start date, completion date, primary outcome, amendments, right? Amendment count. It gives everything, right? Else it just is going to log the exception. Okay. Finally, we are again going to do tool registry, which is all clinical trials tool. And here again, we are just going to register all the 4 tools that we are building. So guys, just check how many tools we have built. Here 8 tools in search tools.py. I think here we built 3 tools, which is 11 tools. And here we have built 4 tools, which is 15 tools, which is fantastic. So you can see our Agentic AI system will be at a point working with 15 different tools, and that is very, very interesting Agentic workflow to work on. Okay. All right. So guys, we are done with building the tools pipeline required for our Agentic AI solution. Now let's go and build the graph. Here we will be building the state, we'll be building the human in the loop and the graph builder. Okay, so let's proceed with building the graph structure.